Today we will try to explain the operation of RC and LC filters in linear power supplies. We will start by saying that the power required by an electronic circuit is normally a pure DC current, that is, an absolutely constant voltage running only one way without changes throughout its operation. This kind of voltage is similar to the one supplied by batteries, whether rechargeable or not, dry cells, and solar panels. Imagine a radio receiver that gets its power from a 50 or 60 Hz AC line. Such an electronic device requires a proper voltage, so we can use a transformer to step the line voltage down from either 127 volts or 220 volts to achieve the necessary voltage, say 12 volts. Once this is done, it's necessary to convert that voltage into direct current, that is, one that goes only one way, unlike the alternating current which reverses its flow at a certain frequency, either 50 or 60 Hz, whatever the line frequency may be. In order to achieve this, we require a one-way valve called a diode. In this particular application, it is called a rectifier. In order to make explanations simpler, we will assume that the electric current flows from positive to negative. Actually, this is not strictly true, but it's easier to monitor the circuit components' current sequence. If we add this rectifier to the output circuit of the transformer, we will be able to take advantage of the power supply for only half the time. That is, whenever the original AC current goes in the proper direction to activate our device, which in this case we will assume is a radio receiver. If we turn on our radio receiver, we will be able to hear the music, but it is mixed with an annoying hum, since the radio is being fed with a pulsating DC voltage, so that the operation of the receiver is interrupted 60 times per second in this particular case. In countries where the line frequency is 50 Hz, that would be the interruption rate. A step in the right direction would be the use of 4 diodes instead of 1 to take advantage of the voltage pulse we are missing. A very frequent configuration is to use 4 diodes in a circuit called a bridge. So instead of having an alternating current going first one way and then the opposite way, we can have a series of pulses of the proper polarity, that is, all of them going positive. Now we will have a slightly improved form of direct current, but there's still a strong variation. This is called ripple. The best way to eliminate or at least reasonably reduce ripple is to add some filtering to our circuit. The simplest form of a filter is a simple capacitor placed at the output of the diode bridge. The capacitor acts as a small storage tank which stores power with each pulse and then supplies power between pulses, just as a water tank would do when water is scarce. In our case, the electrical energy remains present between pulses delivered by the diodes, so the receiver can work in a reasonable manner. With the capacitor at the output of the source, there is still some ripple due to the gradual discharge of the capacitor between pulses. Music lovers will not be happy with this slight background hum mixed with their favorite music. To try to solve this problem, we can reduce the ripple by adding a resistor ahead of the capacitor, so that the peaks are not as intense and the ripple can be smaller. This type of filtering circuit is called an RC circuit, and due to its shape is known as an L filter. Although the ripple is much smaller, performance can be improved if still another capacitor is added ahead of the resistor. This configuration is known as a pi-type RC circuit because it looks as the letter pi of the Greek language. This addition will reduce the ripple even further, but it's still noticeable at a high volume level since the gain of the radio is higher. The last filter we will mention is practically identical to the pi circuit, except that the resistor has been replaced by an iron core shock coil. Now we have an inductor in the circuit, which has a high impedance to pulses and a low opposition to direct current. Of all passive filter circuits, the pi filter using a choke coil yields the best results, reducing the ripple almost to zero. In top-of-the-line power supplies, complex electronic circuitry active circuits are used, but as usual, this results in a higher cost and is used in applications requiring a pure DC voltage with zero ripple. I hope this brief explanation of the basic operation of the power supply filters has been useful to you. Thanks for watching, and please subscribe to my channel. Chao Tarín.